Hey everybody, welcome to Planet Savers, the series program where I will show you how to save the planet with simple do-it-yourself technology that you can make at home, and I will explain the science behind why the simple do-it-yourself technology that you can make at home will save the planet, making you a planet saver. And there's the camera woman.
Go clean some water. I'm all about water.
Clean the water. Keep disrespecting.
Okay, welcome to a really important part 2 Planet Savers. We are going to be doing water filtration using our favorite thing, biochar, make water filters. And the purpose for the water filters is we got people that live down on the Navajo Nation that have like really bad water, and there's a lot of people that live in the inner cities in low-income areas, and like if you've heard about the Flint, Michigan story, then you know you're probably familiar with the urban plight. But the significance with the Navajo Nation is that's a story of bad water that I remember from my childhood. And it really surprises me that people in this day and age that know how to do on-source water filtration haven't created a solution for the people down there. So we're creating a solution. We're going to show you how to build your own water filtration system at home that will filter out heavy metals and other really gnarly cool shit. So yeah, Planet Savers number 2, water everywhere, better stop to think. water pressurizer. It uses elevation and narrowing of the pipe to increase the water pressure to basically force it through the system. And this piece connects to this piece, which is the first filter stage container, the inner, and the water flows out the bottom. I drilled a series of holes, and this is an old Dr. Bronner's bottle. So this is the first component. The water is poured in here, and you fill it all the way up as full as you can without it tipping over or anything. And this, as you bring the water level up, it increases the water pressure down here. Okay, and it forces the water through the filter matrix and out the bottom of the hole. This component sits inside here, like so. Okay, and this is an old 2-liter bottle, plastic 2-liter bottle. This will be sitting on a bed of charcoal, so the water will flow down. So the water will flow down through the charcoal and flow up, and then it'll have another charcoal filter, and then the water will flow up and through sand to about here, and then the sand will stop and the water will flow up through no matrix and be exposed. The water will flow up and you'll be able to visually see water through the first filtration as it comes up and it pours out these holes. These holes are evenly spaced all the way around. And the water will flow out of these holes into the next part of the filter, which took one of these style jugs. It's a gallon jug, a square gallon jug. Took one of those and I cut the top off right at this part. So right where it just becomes a square brick. Cut it off, evened it up relatively nice, and then it has a series of holes drilled through the bottom. Now this particular jug was used in the very first idea of, okay, how well does biochar filter water, and can I just use straight charcoal? So all the radiuses have relatively even spaced holes that are a little bit smaller diameter than the ones that are in the very bottom of the whole matrix. This device sits inside here like so. So the water's going to flow down, it's going to flow out of the holes and go through sand and then charcoal out the bottom. So the water flows down, comes up, comes out those holes, flows down, comes out the bottoms of these holes. This whole unit sits inside this old jelly frosting bucket thingy. But what I did was I drilled a series of holes around the perimeter. This is where I'm going to have the water come out. Have a juice cap, relatively thick juice cap in the bottom of the bucket. And the reason why we have the juice cap in the bottom of the bucket is so that these holes here are up off the bottom of the bucket and are not plugged. And in here, equal to the top of the juice cap, there will be a layer of charcoal, not sand, but charcoal. And this will sit in here like so. So that sits in there, and it will flow up through a layer of charcoal, up through a layer of sand, and the sand layer will come to just below the hole, as is demonstrated in this bucket.
The water will flow down out of the holes into this container. This is already pretty good. The only thing I added was broken pottery on the top to elevate the bucket up off this and allow the water to trickle better through dispersal matrix so that the water's not going right down into the sand. This will sit, that sits in there like that. It will pour out the side and run down because I like watching water flow. It'll be a really neat water feature. So the water will flow down the side into this. There's sand and then charcoal to allow the water to flow through. It has a piece of that over the hole so that the charcoal doesn't go through, and the very bottom is full of large chunk biochar.
Water filtered out really fine. I made some patches to a couple flaws in the design that I took into account when I was like engineering it, and I didn't take it into account when I was building it. When you don't take it into account when you're building it, it can get you. So part of the design fix is this. On this unit, I'm going to cut a sleeve to match this rib. I've got another one of these containers, and that will bring this lip up, like up here. I'll be able to bring it up to here. I'll be back with the fixes in a sec. And that's ASB to pressure fit, and then I seal the seam with like multiple coatings. Alright, that's a good seal. I'll let it cure up. This is exciting. I'm gonna put the pieces back together and then run some water through it here in about an hour after the plastic weld cures up, and we'll shoot some more footage of dirty water becoming clean water.